It's Monday, March 16th, 2020. Coronavirus has stricken the country. This is the last day that campuses are open. I was here once a day, but snuck back in to get the dissection I missed, the heart. Welcome to Coronavirus Classroom with Professor Blue. The only thing I have in abundance is toilet paper, so I'm using that as my respirator. Hopefully this will protect me from any coronavirus that might be rampant on this official day one of our quarantine. Lockdown on education. Welcome to Dissection with Professor Blue, Heart Edition. Remember to always take off your hippie bracelets and bling bling watches before beginning your dissection. So this is a sheep heart, and what we can see here is that adipose tissue packs in around the coronary circulation. This is one of the dangers of having a high-fat diet. So this is a sheep heart that I'm going to use for our dissection. I think my hazmat suit might be a little much, so actually pause. Always use your personal protective equipment, but I'm not actually exposed to coronavirus at the moment, we hope. So, to orient myself, I always like to look for the pulmonary trunk. It's the anterior most of the great vessels. So that's right there. So this means this is the aorta right behind it. So this is my left ventricle. We can see these little ridges right there. That's called the left auricle. And this is the right atrium and the right auricle. And the auricles give the atria a little extra volume for increased venous return. And then what can we see here? The atria are separated from the ventricles by the coronary sulcus. And this is the posterior interventricular sulcus here. The anterior interventricular sulcus. So this is the apex of the heart, this is the base. And the left side of our heart pumps to the entire system, the right side of our heart pumps to the lungs. So let us have a look in here and see what are some of the structures we can see. If we look, we can follow the aorta, and so it leads around into our coronary circulation. So our left coronary artery splits into the circumflex artery that goes around the left side of the heart in the coronary sulcus, and the anterior interventricular artery that goes in the interventricular sulcus. The right coronary artery branches around and branches into the right marginal artery and the posterior interventricular artery. The companion veins that go with them are the great cardiac vein, the middle cardiac vein, and the small cardiac vein. All of those drain into the coronary sinus, and that drains here into the right atrium. So let's just get in here and see what we can see. I'm trying to go as close to the center of a coronal plane as possible. Oh, this is beautiful. So here are some things we can see. This is the left ventricle, and the left ventricle has to pump to the entire systemic circuit. So the myocardium here is a lot thicker. If we think about the layers of the heart wall, this is the epicardium, the simple squamous epithelial tissue that forms the outer layer of the heart wall. Then this is our myocardium that forms the bulk of the heart wall. This is primarily myocardiocytes, but also the pacemaker cells that run through the intrinsic conduction system. So here we can see is our interventricular septum. On the outside there's our anterior interventricular artery, and we can see here's our interventricular septum. This is where the heart's conduction system passes through and is insulated by the fibrous skeleton of the heart before branching into our Purkinje fibers that take the impulses up the ventricular myocardium. When that happens, then the first part of the apex is the first part of the ventricles to contract, and they pull on these papillary muscles that are anchoring these structures called chordae tendineae. The chordae tendineae are anchored to our atrioventricular valves. This between our left atrium and left ventricle is called the bicuspid valve or the mitral valve. And on our right side, I have the tricuspid valve between my right atrium and my right ventricle. So what we can see here is actually, there's still some blood in here. And we can see these chordae tendineae on this side. Oh, interesting. They are totally discolored. And this valve, I bet this sheep had valve failure of some sort. I don't know enough about the pathophysiology, but you can see these ones are healthy and these ones really are not. So it's supposed to be this nice white connective tissue. So we can still see the papillary muscles here in the right ventricle. And again, when your heart beats, it beats from top to bottom. And the atria contract and push our blood through these AV valves, and then as the ventricles begin contracting, your first heart sound, that lub-dub, that lub comes as the papillary muscles pull on the chordae tendineae and snap the atrioventricular valve shut. Then they finish contracting and push the blood out of the pulmonary artery and aorta. The pulmonary trunk goes to our right and left pulmonary arteries to the lungs, and the aorta goes out to the systemic circuit. This is the brachiocephalic trunk we actually have off of it. So now, what else can we see? Our other structures that we should be aware of, these muscular ridges inside the ventricular walls are called trabeculae carneae. The muscular ridges inside our atria are called pectinate muscles. So let's have a look in there. Well, you can see in this left atrium, you can see those little muscular ridges. I'm just going to cut this valve. Okay, oh, beautiful. So here we can see the pectinate muscles in the left atrium. And this is the bicuspid valve that we just cut. The chordae tendineae, papillary muscles, trabeculae carneae, interventricular septum. We can tell that this is the left ventricular myocardium because of how thick it is. This ventricle has to work harder to pump blood to the systemic circuit. And then let's see what else we could recognize. So, I think that's kind of the most important stuff we're going to be able to see. Oh, let's look for our semilunar valves. So the second heart sound comes when your ventricles finish contracting, they push the blood up out of the pulmonary trunk and aorta, and then the ventricles relax. And for a moment, all four chambers are in diastole or in a period of relaxation. So the blood will then pull back and snap the semilunar valve shut, and you hear the dub sound. So let's see if we can see that. Usually, it's easier to, oh, here's a beautiful, beautiful shot. So if you see, I'm coming through down the aorta here, and this is exactly what blood does. It pushes back on this semilunar valve, and this semilunar valve snaps shut, and we hear the second heart sound. That prevents backflow of blood to the ventricles while they're in diastole. So the AV valves here that are anchored to the chordae tendineae prevent backflow of the blood to the atria when the ventricles are in systole, and the semilunar valves here prevent backflow to the ventricles when they're in diastole. So there's the pulmonary semilunar valve. Oh, nope, that's the aortic semilunar valve here between the left ventricle and the aorta. And then between our right ventricle and the pulmonary trunk is the pulmonary semilunar valve. So let's cut that from the front. It's kind of tricky. I didn't do the best dissection to see that. But regardless, there's a pulmonary semilunar valve that does the same thing the aortic one does. So I think those are the most important things we need to see. Left atrium with our auricle, left ventricle, anterior interventricular sulcus with the anterior interventricular artery and the great cardiac vein. Coronary sulcus with my right coronary artery, my right marginal artery, my small cardiac vein. Coronary sulcus, posterior interventricular sulcus with my middle cardiac vein and my posterior interventricular artery. Circumflex artery is running the rest of the way around that coronary sulcus. If we look in here, this is my left ventricle, my right ventricle, left atrium, right atrium, tricuspid valve, bicuspid valve. aortic semilunar valve. All right. Thank you for joining me for this edition of Coronavirus Classroom, Dissections with Professor Blue. Hope to see you soon, actually face to face.